So again, welcome everybody. Thanks for joining. Um, Today, we will be talking about this vast platform AI assistant, which is about integrating LLMs into live Smalltalk environments, like VAST in this case. So first, I would like to say sorry for another AI talk. I know that we have been watching many of these AI presentations, but to be honest, we at Instantiations, we watch many of the, if not, I think probably all of the AI presentations that were given in this space, in the UK Smalltalk meetup, and we learned a lot from those talks, and we benefit from them. So as you will see later, part of the reasons of why we did this project open source is try to give back to the community. So when Giovanni asked us if we wanted to present something, we believed that this was a good idea to talk about this. And now, in the same way that we learned when we saw the other AI talks, we are hoping that at least there is something that you can learn during this talk, or grab some idea, or even source code, or whatever. So once again, thank you for all of the UK meetup organizers, Giovanni, Francisco, team, everyone involved. Thank you very much for giving us this opportunity to talk about what we are doing and what we believe it's interesting. So we will see. Before going further, I wanted to let you know that luckily I am not speaking alone. We have other two amazing engineers, Johan and Kris, both work at Instantiations. They will be talking and presenting together with me. So they will introduce themselves a little bit. But also I wanted to also clarify that there are other members of the VAST team that have been working on this project. Even though it's only me, Johan, and Kris, which are talking right now, this is a whole team effort. So I wanted to also thank the VAST team for this. So about me, a very short intro for those that don't know me. I am a software engineer. I worked for Smalltalk for the last, I don't know, probably 90% of my career. I did a PhD in Smalltalk, and then I worked many years in Smalltalk. And 10 years ago, more or less, I joined Instantiations to help the support and the development of the VAST platform. And more or less 2 years ago, I took the role of the VAST team lead. So I am now leading this fantastic group of folks developing the VAST platform. Okay, so about the agenda, we will start first with a small introduction to how we do AI at Instantiations in general. We will then go to a small landscape about this particular project, the AI assistant that we are working on. And then we will see many demonstrations, many live demos for some of the use cases, because it's really impossible for us to demonstrate all of the capabilities or use cases that present this tool. We have been using this many months now. It's quite a challenge to kind of enumerate things to show. But at least we are going to do our best and demonstrate a few use cases that we believe are interesting. And then we conclude with what is coming soon, which, by the way, there will be also a demo about what is coming soon. And then we will finish with some roadmap and next steps. So we already clarified the question about, the question about questions in the presentation. So that's, I hope I was clear. And then the other thing I want to clarify is that we would like everybody to follow what we are doing. So if, for example, the font is not looking good, or it looks too small, or something is not clear, or you might, whatever that we can adjust, let us know. We put bigger fonts in code and everything so that ideally everything should be good. But if it's not, let us know. Okay, so why are we here talking about this? Besides that the UK invited us, why is the reason why we are here? The reason is that we believe that AI transforms how we understand, maintain, and evolve critical and log live system, which is fairly common in our space. In the case of Smalltalk, in the case of Vast, we have plenty of systems with these conditions. Many of us have been working with Smalltalk systems for many years. We know how powerful it can be, but also how complex these systems can be. We have systems of 20, 30 years old with 5 million lines of code that have been touched by 100 developers over the years. So you know that it can get complex. So we believe that AI helps surface this context faster. It gives us better ways to explore the system, understand what makes them work, and allow us to make changes with more confidence than if we do it completely blind. So we believe that with AI, we can augment what we are already doing so that we can work with these systems more efficiently. So this is exactly what drives our approach to AI at Instantiations as a whole. First, AI has to be embedded into real systems and real workflows and aligned to how people are actually doing their work. It cannot be like an isolated, disconnected tool somewhere. And second, and I think this is really important, we focused on balance, because innovation only creates value if it's sustainable, if it's stable, if it maintains trust and avoids introducing new risks. And you see this everywhere, not that we do at Instantiations, not only with the AI tool that we are going to present. You see that for a vast platform, for example. We try to preserve as much as we can backward compatibility, but also keep evolving the system. So it's always about finding the right balance. And we apply this same principle in almost everything that we do. And that's why we believe this responsible evolution, that's how we call it, is so important. The responsible evolution is our deliberate approach to advance systems over time, strengthening how the people work, and ensuring that the system maintains stable, understandable, and built to last, which is what our customers actually really want. So I don't know if you have heard about this responsible evolution term that we crafted just recently, but it's actually the way that we have been operating for many, many, many years, and as a whole company. And in this case, the vast platform AI assistant is just responsible evolution in practice. It's an example, because we didn't add AI for the sake of it, just because everybody's doing it, and we just put there an isolated tool. We are trying to embed AI directly in the vast development environment, working together with the tools and workflows that our teams already rely on. We didn't want to reinvent the wheel. We wanted to keep what our customers were doing and empower them. So in terms of responsible evolution, our principles, that are 3 of them, are the following. The first one is enablement. We want to help developers understand and navigate this complex system that, as I told you, is very common in our space to have really complex and big systems. So we want to be more efficient to understand these systems. The second pillar or principle of responsible evolution is continuity. And by working with existing applications, without requiring a complete rewrite or complex migrations. That's how we allow continuity. And finally, augmentation. By assisting developers with the context-aware insights of the system, while keeping these people in control and at the center of the tooling, is what allows us to augment the existing developers and augment the existing teams. So at the end of the presentation, I will put a link about responsible evolution. I think it's really important, and I encourage you to take a look maybe when the presentation is over. So now getting a little bit more technical now. So what is this tool about? What is this vast AI assistant? And basically, there are three biggest ideas or concepts. First one is seamlessly and deeply integrate natural language and AI assisted development into VAST. The second one is to empower the AI, and this one is the main differentiator from our tool, is to empower the AI to autonomously explore the system architecture to gather context before actually giving a reply or provide code or suggest modifications, etc. And you will see later in this talk why this point is probably the most important one, or our main differentiator. The last one is, and we have noticed this ourselves over the last couple of months, is how this improves developer productivity and daily workflows. So with this kind of capabilities, I think it's becoming fairly clear that AI integration is the next evolution of BAS development. So that hopefully gave you an introduction to how we are approaching AI at Instantiations, and in this case, in particular to VAST, but the same principles are applied to other AI initiatives that we are doing at the company. But the talk of today is the AI assistant. So with that in mind, I will pass it to Kris, where he will show you, he will start explaining the actual tool. Okay? So let me
Mario,
sharing.
could you go back one page? I just wanted to get the page before the project landscape.
Yep. Sure. Yes, this one. Yep.
Okay, thank you.
Sounds good.
Yep, it's good.
Okay. No worries. I didn't mention this, but if someone wants the slides after the event as a PDF or something, let us know. Before, I know the recording will be available, but if someone wants the PowerPoint, not the PDF before the YouTube becomes available, let us know. That's not a problem. Okay? So now, if maybe it's a good time, if someone had a small question, I can check it now, or otherwise we can pass it to Kris. Okay? So, Kris, I let it to you. Did we lose Kris? Let me see.
So look.
No,
What happened?
he's there.
It's the classic trying to get your screen to share, isn't it?
Yeah.
Don't worry.
Let me see. Give us 1 second, please. Okay.
So-
Meanwhile, while we wait for a second for Kris, any questions so far? Any slides you want to see again? Let me know. Otherwise, if I don't know if Kris is not back in 5 minutes, I can do his part. It's
Is
Well, if you want to
he-
fill the space with a question, I've got a question. So one of the things I'd be interested in understanding, I don't know if it's going to come out in the presentation, is how type inferencing fits in here. Whether you did any explicit type inferencing or whether the AI has inherent type inferencing powers.
That's a great question. And actually, it was one of the ideas for the next steps. So, great question. It was one of the, as you will see later, what we have right now, it's a set of tools or functions to do multiple things. And one of those that we were planning to add next is one for type inference. And we know how to do it because we already did it in, for example, for the security scanner that we are working on. So it's just a matter of time. But yeah, it's a great question. Sometimes you can see that the LLM tries to grab the type on its own. So it tries to look for senders and tries to understand where the a certain variable is created. But it's not a real type inference like we can do. So yeah, it's a great question, and it was actually one of the items I had prepared for the next steps, because that greatly we believe it would greatly improve the quality of the response of the LLM.
Thank you.
Yeah, so it's one of the things we haven't done explicit experiments with. But if we take a look at what it's doing, the LLM is a text processor, right? So it's actually, if your naming of the variables is done well in the source code, then you will notice that when it searches for a particular class or when it searches for the behavior of certain method, it will then look to the other classes which are being used. So it's not doing any type inferencing, but it sees like a method with a variable name which has a class name there, and then it follows that. So that's something you definitely see, which is one of the things that Mariano said. We will to investigate whether explicitly offering it the type inferencing, but trying to see whether it has inherent type inferencing, I think that's a feeling. I don't know. We're experimenting with it. So is Kris not back? Where is he out of the chat?
I don't see Kris. I mean, he's in the call. I can see him in the call, but I text.
Could it be that he had two devices and the second one is in and the other one not?
I don't know,
You
but
have a back channel to him.
Johan, do you have any way to send him another message from? I just sent him Gmail, but I don't know. I think I can continue, Johan, with Kris.
Yeah, if you can.
Yeah, because I think I don't know how much time.
We all rehearsed in parallel, so we just saw each other's things once, so we're a little bit in panic now.
Yeah. Okay. Let me try to comment what Kris was about to present. Okay. Okay. So let me.
You're keeping us all on the toes, aren't you? You're just like, trying to build the excitement here.
And by the way, if you see Kris, because again I won't see meet now, but it just interrupt me. Okay.
Yeah.
Okay, I will share again. Screen. Okay. And now I will. Okay. So now you should be watching the GitHub screenshot. The first thing that we wanted to clarify is that we set this project up as an open source project on GitHub, so you can grab it, you can explore it right there. There are many reasons why we did this. One is because we have explicit interest from many of our customers that they wanted to collaborate with us on this effort. So that's why we make it open. Another one is to give back something to the community. Of course, some of the parts of this tool are VAS specific, but there are a lot that could be easily be ported to some other Smalltalk dialect. The license, it's the Apache. What's the Apache license? I think. Well,
yep.
I need to know it. Yeah, the Apache license 2.0. And something important is that, as you can see, the name of the repository is the AI VAS Platform AI Assistant, but currently it has a single app, which is called Gemini Chat App. And this is because so far, what is available right now on GitHub, it's only an integration with the native API from Gemini. We have a working version internal that we are going to submit soon that allows other LLMs. But I will talk about that later. So right now, if you go right now to GitHub, it would only have support for Gemini. But again, stay tuned for the end where I will show others LLMs. And we didn't use chat in the name of the repository either, because as I said, we are planning to add more things than just chat. So that's why not we didn't include chat in the name. Finally, I wanted to clarify that this project is heavily under development. So check it every in a while, because you will see new versions coming all the time. Okay. So then about the current status is that we, as I think I mentioned this at the beginning of the talk, it already is helping us for many months now with the augmenting developer productivity. We are using it daily internally, and we hope that you guys can do the same. So that's why we're here showing this to you. But as we mentioned, it's still in active development. So check on GitHub what is going on. And stay tuned for the slide at the end about roadmap and next steps, because there I will show a few more things. So here you can see a little screenshot about the tool, but we will see live demos in a couple of minutes. Okay. Johan will also demonstrate a lot of the capabilities of why we already augmented our productivity, and hopefully what Johan will show, it will help us understand why we are claiming this. Okay, and this slide, I think this is the key aspect of our tool. I think this is the most one of the big differentiators. Like, if you who use an online web chat of Gemini, or I think someone is asking if I can go back one slide. Sure. So I think I saw somehow I can now see a small slides of the Google Meet. So I saw someone ask me to go back one slide. So here I am. Okay, so now I guessing I can proceed. Otherwise, let me know if you want me to go back again. And what I was saying is, if ever of you went to the online web-based chat like Gemini or ChatGPT or wherever, and you start asking questions about Smalltalk, and let's say you share a method, and you ask, okay, help me with something about this method. And the guy said, okay, yeah, I can see this problem in this method, blah, blah, blah. But then I would need this other method, because in that method, you are calling another method, right? Or you can be reference a class that you didn't attach. So at the end, you will be copy pasting and attaching everything that the LLM asks you because he needs more information. So what we actually did, it's we did it originally with Gemini. Gemini calls these functions. So what we did is that we implemented our own functions so that the LLM can do those queries automatically in VAST. So instead of me doing file outs of my code, attaching the file outs into the web console and asking, the LLM can autonomously get into VAST and call the different functions that we provided and get the necessary information automatically, so that then the reply could be much better. So this is, I don't know how many of you are frequently with this, but this is the one of the main ideas. There is a small difference between what is a function and a tool, which I'm not expert to exactly tell the difference, but you will see that in many the jargon in many LLMs, they call it tools to this. Gemini calls them function, but I think there's small difference between function and tools, but I don't know exactly. But we will see later with other LLMs that this is called tools in other places. And here in the screenshot, you can see, for example, I don't know, tell me what method categories are used on Gemini chat app. And this guy does a single function call in this case, which is called get class methods, and with some parameters. In this case, the parameter is Gemini chat app, the class, with no source code. There's no need to grab the source code in this case. And it gets the methods, and the guy with that, it can answer, okay, the categories used for this application were private and loading removing, for example. This is just a simple example. And here it's a list of the functions that we have developed currently. As I said earlier, we are planning to add more. For example, one typical rule we want to, one typical function or tool we want to add is to run the type inference for a given, I don't know, let's say you specify a method and a variable name, and you say, okay, run the type inference for this variable and answer what is the potential list of or the types for that variable. So we have quite some more tools coming up that we have some ideas to do, but we still have many. And actually, I can run this in a second. I can run this same script on the live chat and show you. But I'm guessing you get the idea of some of the function. It's like the typical API that you would want from a Smalltalk dialect when you are developing or querying the system, like find implementers, find instance variable accessors, or find instance variable references. Actually, is this find references to globals, get class comment, get class definitions, get class hierarchy, get class methods, subclasses, blah blah blah. So there are many. The last thing I wanted to show you before getting into the to the next is this other example where you can see the tool has nice markdown rendering, so we can render and interpret the markdown from the LLM response and render that nicely. So here I ask, for example, tell me what other classes Gemini chat window uses and what for. And it lists like, okay, this class relies on these other classes because of this, blah, blah, blah. So maybe if I have a second, I can go live and demonstrate this to you guys. So let me, now I should have Windows now, and you should see a vast workspace. So I will open this tool, and I can show you a few small menu items, or maybe something simpler. So for example, from here, you can choose which Gemini model you want to use. You can set your API key, which I won't do it because it will show my key right now. You can inspect chat, inspect load, this kind of debugging tooling. And you can save chats, open save chats, and you can attach files. This is very, very useful, as we will see later. And before you start any chat, there is what is called a system instructions, which this is very cool. This is kind of imagine like a pre-prepared text that gets appended at the beginning of the conversation. That's an easy way to comment what this is. But basically, over all of these months of development, we found out that by telling some more context to the LLM, we get better results. So basically, we are saying, okay, you are the AI assistant that helps the user develop in the BAS platform environment. You can say, for example, ensure that all code and snippets are valid. So you tell the LLM to call the function to validate code before giving it to you. You can say, okay, focusing on user in writing, debugging, understanding code. So I won't go over, but this is kind of a text that helps the LLM to understand what it will be doing. And that is kind of even before any of the conversation. So now, if I go back to, for example, the preview thing, I can tell, okay, tell me and group by functionality your available tools, something like that. This is what I showed you earlier. So when you see the three dots there and you see the send is grayed out, is because Gemini or the LLM, it's actually working. So depending on the how busy the LLM is how long it will take to get back to you. Depends on the model. For example, if you use model 3.1, it usually takes much more than one of the Flash models. Those are usually much faster. And here you can see, okay, here the list of the tools available to me. And you can see, okay, for code search and cross-referencing, you have all this fine and a description of what each does. The same for listing applications and classes. For code validation and debugging, we have one tool to validate code, and I want to get the suspended process. So basically, we can analyze the stack trace of a debugger, which is very cool, and some functions to work with the files that we can attach. And Johan will show this later. And I think the question that was written in the slide was something like, tell me what other classes Gemini Gemini chat window uses and what for. I think
Yeah,
I made a
got it.
typo,
Yeah. Gonna,
uh,
and other,
something like that.
other,
Uh,
other
other.
classes.
Yeah, I think, yeah, they're
I don't-
still quite good at understanding typos, but yeah. Oops,
Oops.
I made a, well, maybe we'll get it anyway.
Just continue. I will come back to the same thing. So
Yeah, okay. So, something I didn't show, which I wanted to show, is these thoughts that you can expand. These are if the LLM supports thinking, which that's a feature or not a feature of the LLM. Some LLMs support reasoning or thinking. It depends on the LLM. We can grow those thoughts and we can render, and you can basically see what the LLM is thinking and why it is calling the different functions. So this is very, very useful to understand why the LLM is doing what it's doing. So now I can see more or less the same screenshot that was in the presentation. So you can see some of our other classes that this one uses. And of course, you can always click and open from here. And I think that's more or less enough for what I wanted to show. So this was maybe the most basic example with Gemini. Now all of the examples that you will see with Johan are also with Gemini. And at the end, I will show some more example with other cloud LLMs and even some local LLMs. But before that, and before actually passing it to Johan, was there any question that we couldn't reply, or we are good? You're good? Okay, awesome. So with that in mind, I will stop sharing and I will pass it to Johan, which has the most interesting demos. Okay, there you go, Johan.
if I don't get disconnected.
Yeah, I'm back. Sorry, I accidentally closed the meeting and I didn't realize, and I just started presenting because all I could see were my slides. So I only realized when I was more or less done.
Oh, sorry about that, Kris.
Yeah, no problem. I'm sorry for you to have to take over.
No worries.
Okay, so you should be seeing my screen showing a rather wide, vast platform. So my name is Johan Brichot. I work with Instantiations a little over 1 year now. Before that, I was a co-founder at YesPlan, which is an online web application system built with Seaside, Smalltalk. For 15 years, I was doing that approximately. And before that, also working in Smalltalk. So I guess, Mariano, if you spent 90% of your career, I think I should say 100% because at university for me was also Smalltalk. So yeah, doing Smalltalk for more than 20 years. And I will actually, this part of the presentation, try to give you a couple of examples of the use cases of what we have been using the vast AI assistants ourselves at Instantiations. So generally saying, as Mariano said, I think we already experienced this as a nice productivity tool, but I'll jump to the conclusions later and let you draw the conclusions and let's talk about that afterwards. So we've actually been using the vast AI assistant itself, or in this case, it's the Gemini AI assistant, because what we will be demoing is only the use of, or what my demo here is only using Gemini. We've actually been using it ourselves to build the tool itself, right? So I will actually show all those examples that I will show is in the development of the tool using the tool itself to develop. So one of the things we actually hit a couple of months ago already was a bug, which we then used the Gemini AI system for to try to investigate what it was. And this snippet actually triggers this bug. And why did this bug pop up? It's because we are using the streaming HTTP API of the Gemini API, the streaming GET client. So what you see here is the HTTP client of VAST doing 100 requests in parallel in a streaming fashion to just Google.com. So I will just launch that, and what you will see is that we will get an open debugger. An open debugger with the font is a little bit too large, but there's actually multiple ones which are going wrong. So we hit a bug here, and one of the things we said, well, let's actually try to see what's going on using our Gemini AI assistant. So when you go into the tools window in VAST, you find the Gemini AI assistant when you loaded it. That's the window you saw in the previous slide. So I will just say, well, there is an open debugger. Explain the error and propose possible solutions. That's what I will just type here, right? So that's maybe the solutions, right? Okay, let's go. So it goes off, and what we're demoing here, of course, is that it will immediately start investigating. In this case, it will show the thoughts. It will start investigating the first thing that it will do. And this keeps open, but this is a small thing we need to improve, that the function calls, you will see it collapsing all the time, but that's something we need to change. Anyway, the first thing it does is it calls this Gemini function, give me the suspended process. So we give it access to a description of the suspended process, which is open in the debugger. And it starts off analyzing. And now we could, of course, start waiting until the system comes back. But in order to save some time, I, of course, run this experiment again, because this dates from a couple of months ago. It's a bug we actually fixed in VAST 16. So it's already part of the current release. Sorry, in VAST 15. Now I was one version too fast. So I open a chat here. You can save chats and you can reopen them, and you can actually also just continue them, right? So that's actually a complete snapshot of a complete chat. So you could just start typing here and continue the conversation, just like you can also do that online with the Gemini chat if you have tried that. Or I think ChatGPT, any LLM does that. Anyway, so actually I had the same thing here. Well, I phrase it a little bit different, but I asked investigate the error in the open debugger for possible causes. And what it actually came up with is very accurate after investigation. So we took a look, it gave us some possibilities. There is a race condition. And indeed, inside of a class inside VAST, which is the ES stream controller, which is part of the async framework, which is being used inside of the streaming API implementation, a race condition was occurring. And in this piece of snippet, and what it explains here is that first it sets the pending events, and then you're actually doing the guard callback. But in the pending events, you're actually scheduling other asynchronous actions. That's very roughly what's written there. It set other asynchronous actions, which will in fact set the particular variable to false. And in the guard callback, you check this in the assertion, and in the assertion, you said that the callback should be false. So it set this to true. Anyway, it sets this to the wrong Boolean. So the assertion fails because these things are happening one after the other, and the system crashes. So that's what it made by analyzing the stack, and it also has access to the rest of the source code. So if I collapse this, so the Gemini here is actually still busy coming up with that, but as we have the pre-baked chat out of the oven, so I feel a little bit like a kitchen program where you have set the cake into the oven for 1 hour, but actually we made one before. So this is what is shown. So okay, that it actually proposed me something, which is introducing it as a critical section. So you cannot have in between these two statements that the scheduler actually switches to the other process, and that the error condition goes off. So yeah, that's a possible suggestion, but in our case, when we then try to run some tests and things which I cannot or would lead me too far to go into, it actually also broke some tests. So yeah, that didn't really work, so we're not going to apply that change. And so we said, okay, that actually breaks some tests. What's another possible solution to change this? And so then it came up with the solution we actually integrated into the system, and it's just reversing them. So first setting the guard fallback and only then scheduling the other events to do the asynchronous one. So that's what it suggested here. Gives us a little explanation. And of course, after thorough investigation, we confirmed that this is a good solution, but it helped us immediately narrow down and gave us some possible solutions so we can more quickly find a possible bug fix for this. So I will actually have to merge this in, because otherwise I will get some errors again. So as you notice, the chat is actually still running here. You notice that by the 3 dots here. Also, as Mariano said, you cannot send something. And also what we did, and this is just a little bit of a statistic for us, when we hit some rate limits, for example, of that's how many tokens are in the current context window of our chat, and the maximum context window for the current model. By the way, something we didn't show yet, because you are now a little bit disorganized, is that you can select the model here. So right now, if you download the source code from GitHub, you only have a version which works with Gemini. As Mariano mentioned, we will show other LLMs afterwards, and this version will come online really soon. But these are all the LLMs you are able to gather. There's also a debug if you want to go and inspect the objects of the chat and the log and so on. And the other window here allows you to open, save, or add a file. And that's the next thing I will actually do. So here it tells me you can apply this. So yeah, by clicking on this piece of code, that's of course what you all noticed. I can actually take a look at what Gemini proposes me to change, and we open up a change window. And right now I applied the change, so there is no change anymore to be done. So that's the first case. We actually applied it to our work. So I'll now close the debuggers here. They will be in my way. But sometimes an error comes in production, and the only thing you have is not a live debugger, but a stack trace. So I'll open up a new chat, and I'll actually just a very simple example. It's like that was should be in here. Where is it? Where's my stack trace? Here.
No, you put open a conversation instead of add a file.
Oh, thank you, Mariano.
Click on open instead of add file. Yeah.
Thank you. Thank you. No, I was confused. You see. Okay, so this actually contains a stack trace, which is just a save, a textual save from actually my window. So I can tell it, well, investigate the stack trace in the stack trace file and describe the problem. So that's one possible use case of attaching files to any chat, but I'm pretty sure that many others of you have used chats and you attached pictures and other things. Other use cases we have actually applied, which I will not be demonstrating right now, will lead us a little bit too far, is attaching log files, even C files, C header files. Another experiment we were still running is that we were using the Gemini AI assistant to help us write a wrapper for a C library. And that means you need to produce many different wrappers and in the Smalltalk version of that, so the wrapper around that. And you can take a look at the C header file. And actually using an LLM for that kind of avoids that you have to write a parser for the header file. And you can just ask it, well, take a look at the header file there and propose me all the Smalltalk classes and methods I need to add. And those things are actually working, but we're not quite end of the experiment there yet. Though there have been some successful things there as well. So that's another use case. But for example, as you can notice, I really made a really simple stack trace, so not a real one. I just did a division by 0 in my workspace, and of course, the LLM was pretty fast in figuring out that that was the case. In the meantime, my chat, which I launched interactively with the Open Debugger, came back with an answer. I'll quickly take a look at it, and you see it's completely different than what I had in my saved chat, although the question was maybe a little bit phrased differently as well, but even if I would have phrased the entire same question, this is, of course, what you would expect. You will never get the exact same answer from the LLM. You will get something else and something related. It does come up something related, something similar, doesn't come up with something completely different, although it might. I mean, that's kind of the so yeah, so sometimes I've actually been running this a couple of times, the same experiment, and sometimes it nails exactly the same one. Other times it comes up with something completely different. So yeah, that's also something to take away from our experiences, of course. Let me close this one again, and then open a new one. All right. So I will tell it. I just want to have some text in there. The vast AI assistant window is implemented in the Gemini chat window class. Describe this class. All right. So that's a little bit what Mariano also, what I just needed here, so that it gives me a couple of responses with some references in there. So don't hesitate to interrupt if I'm going too fast, or if you have any pending questions, burning questions on your tongue. So don't hesitate to do so.
Well, I can ask a question. So how did Gemini come to understand the Smalltalk language? Did you have to do anything specific to explain the language to it, or did it just intuit it?
No, it appears to have quite an understanding already, even of vast. It does have more. So when you take so we didn't change anything because we're using a Gemini, the online Gemini model, right? So we didn't adjust anything. We're just using the API. The only thing we did is having in the system instructions, giving it to say, well, you are an AI assistant that helps the user develop in the vast platform Smalltalk environment. And we give it some instructions because we tell it, use your tools. Also, if you propose code, first validate the code. So one of the functions we offer it is validate your code. So which it sometimes uses, sometimes not, which is really interesting if you start looking at the thoughts, for example, that sometimes I get some code back, which even might, it can even happen that it's syntactically incorrect. I mean, putting temporary instance variables after the first statement, for example. And then I tell it, please validate your codes as we told you, and it starts doing that again. So yeah, that's a little bit of the experience, but we didn't change anything. In our experience, it has quite some knowledge about Smalltalk, not as much as any of the other programming languages, as you might assume, but even of vast. So it's not completely alien, and we didn't have to train anything yet, let's say.
Okay, and you've used the magic word train there. So have you actually looked at having training local models on a specific image? Because if an image has been built up over the years for a particular application, you have lots of things that surely Gemini wouldn't know about.
Yeah, but that's what the functions, of course, are used here. So it doesn't know about this Gemini chat application. So we're just talking about it, and we say, well, you have to call back into the Smalltalk image using these functions, because we give it all the tools. We say you can investigate classes. So look at it. I open the thoughts here. It's going to do function calls, and it's going to ask, well, what is Gemini chat window? And then it's getting the class definition, it's getting the comments, it's also getting all the methods of the Gemini chat window. So because I was explicitly telling it, I want you to explain me this, right? But with the same thing, which the stack trace or the debugger open, it will see a couple of classes and methods there. But if you then take a look at the thoughts, you will see that it's going to do a lookup of those thoughts. So for example, the guard callback, which is inside of that, is one of the methods which are being sent inside of there. It's going to ask the implementation. It's also going to dive into the implementation. That's how it, yeah, I cannot say this otherwise. That's kind of how it figures out that this set pending events actually spawns other asynchronous processes, right? I can't like derive this from any knowledge it could previously have. Other things, for example, and I will show later on. For example, I asked it to implement me a text diffing algorithm, and for that, it didn't have to do any calls. Of course, it was just poof, generating this out of its memory. Let's say.
Thank you very much. I noticed that Mr. McIntosh has his hand up.
Right, John, go ahead.
there was a question about LLMs and how much Smalltalk they know. So there's been discussion about nano LLMs and building your own. And so I've collected, well, I had about 355,000 Smalltalk email threads in my email system. Plus there's like 48 books from ESOC. So I've collected about 12 gigabytes of Smalltalk related information, which when it's parsed down, ends up with about 48,000 question answers about Smalltalk. And I've been trying to actually build an LLM, a nano LLM with that information. And it turns out my constraint at the moment is that I can't get 3 or 4 hours of time on a NVIDIA cluster to actually build the weight model. So, and as soon as that is done, then, and I do some testing to understand if there's value in that model, then I will make that available to the community.
That will definitely be an interesting experiment. I've been noticing that you've been announcing that, and yeah, maybe Mariano will talk a little bit also about some ideas and intentions we have for that, the instantiations at the end. So definitely come back to that subject. All right.
Thanks for doing that, John, by the way.
One other thing, there was discussion about MCP servers. So I put in the chat, I had built an MCP server for Squeak and for Quiz, and that's available in GitHub, which allows you to interface Bot AI and ChatGPT and to talk to a Smalltalk image. I think the magic here is that basically you're providing information from your Smalltalk information in terms of the code and the structure and the running environment. You know, the AI system is then taking all of that and building, you know, what's being shown here.
Yeah.
So the approach I took was to come from outside and reach in, because that was an easy thing to do. This approach, in a sense, it's better because you're working with the tools inside the image, and then you're sending information out for evaluation. Yeah. So, but it's exactly a lot more work that you need to build the whole editing.
Yeah, exactly. So the approach we have compared to an MCP server is that we wanted to extend the existing development environment, right? So have it completely integrated. Right now, it's still only like a subset of what we intend to do. So you will notice. All right, I'll probably continue, and we can continue some more discussion afterwards. So another thing, as I mentioned, we've been using the Vast AI Assistant itself to develop it. So for example, when I click on this class here, well, it should actually open on a class, so why doesn't it? No, that's this one. So what we open here is like a single class browser in Vast, and that's because the first implementation, when you were clicking on something, it detected in the chat as a class name, was sending browse, right? But that's not, I much more prefer the class hierarchy browser in Vast. So that's what I told the assistant here. So when I click on a class name in the chat window, class browser opens. It would be better to open a class hierarchy browser, right? So I already put it a little bit in the context of the Gemini chat window, and I just continue talking about that. And as previously, the same thing, I just ran that earlier as well. So I'll just open the pre-saved chat here, and you see did exactly the same thing. We described this class. So it's actually giving me a description of the class with its methods and etc. And what it makes up of that. You can use that to generate documentation or to understand the system, of course. In this case, okay, I ask it, well, I want to have the class browser as I just previously did. And it actually goes off as you open, if you're opening the thoughts, it goes off, as you mentioned, see here, looks at, okay, what are all these methods? I want to understand, or that's the impression you get, right? It tries to dive into all the pieces. It goes to look for what does this user understand by clicking somewhere. So it's definitely finding stuff which handling the callback of a click. So because I never told it that. It's also not even in the code comments. We, as you mentioned on the source code on Git, he didn't provide a lot of comments yet. But it actually finds the places where such an element code is and class is displayed and where it's done in a button pressed and so on. So I'll keep the thoughts open because I want to come back to them later. But in the actual answer, it tells me, yeah, well, the Fast AI assistant, what normally you do, and this is completely correct, this is how the browser tools in framework is actually defined. So there is a setting, if you call ET tools browser with the class symbol, you get the class browser class, which I just opened. If you ask for classes, you actually get the hierarchy browser. You take a look at the thoughts, it actually figured that out by finding a method called open hierarchy browser, and it did exactly this. So let's see, if I click on this piece of code, it shows me the differences, which this is right now the implementation, the referenced class, we just send browse. Well, in order to do that in Vast and open the hierarchy browser, well, you should do that. So I'll just merge the code in. And then let me click on a class, and then you see that I get the hierarchy browser open. So that's one of the things. I'm just showing small things, of course. Sometimes the original one where we really did it, we needed to do more refactoring and so on. But another thing is, well, this is cool, but as you notice, sometimes it will also give me a method reference. And in this case, when I click on it, nothing happens. That's because this is a reconstructed chat. Some of the code is already there. I took a little bit of the code back out in order to demonstrate. When we did the same thing, it actually, there wasn't showing anything, so we had to do a little bit more, but it shows, it demonstrates the same thing. So what I will say here, I know I don't have to say anything anymore. I have to go to here. When a code block in the chat contains a method reference, we also want to open a class hierarchy browser on the method, which is the next thing I told it to do. So it went off and said, well, we need to add support for that. And then you see the next version of the button pressed in method, where an entire piece of code is injected before. And some of the times, a small error was in there. I will not show that now because otherwise I will also need a lot more time. But then I said, okay, there's actually an error. There's an open debugger, just as I showed in the previous example. And then it kind of figured out, oh, okay, I need to adapt it like that. And that's how this went on. So for example, if I then click on this, now it will show me the method completely selected. Of course, as a software engineer, I will try to investigate, but now I just clicked, accepted it, and tested it, right? Which is what I really did. So first of time, you just accept it and try if it works. Then you'd start taking a look whether what it does, is this acceptable, right? So that's another thing. But some of the people who are active users of Vast, they might have noticed that the differences window I'm showing here is not something, not a tool they're accustomed to in Vast. Well, one of the things we noticed, of course, is if you're going to start to work with a Vast AI assistant and having code injected, is that you're going to have to need a lot more comprehension of a lot of changes coming in, and you, as a developer, you have to review these. You don't want to just have the system go off and having injected 100 lines of code everywhere without you reviewing it, or at least that's our vision. We want to have the human in the loop support in the Vast AI assistant. And one of the first things we are then picking up right now is improving the existing merge tools in Vast. And for that, I'll open the completely saved chat, so I'm not going to even start doing that interactively. So I can close this one because I merged that in. So the idea was, okay, this is nice. We already use Scintilla. Scintilla is a C library for text editors, and it is the supporting text editor widgets in Vast. So everything of all the codes editing windows, they are using Scintilla. And there's a nice tool that exists in open source, which is WinMerge, and WinMerge is showing a 2-pane diff very nicely using Scintilla in the background. So we said, okay, we actually want to do this in Vast, right? So we started off with a chat saying, well, Scintilla is integrated in the Vast environment. Can you find which application provides the integration? Just to trying to narrow it down where the Scintilla is. So yeah, it found the Scintilla support, gave me the answer, and this is Scintilla support. And I said, okay, well, our goal is to build the editor in Vast that allows to compare source code changes, like the open source WinMerge tool, and gave it a pointer to GitHub. In this case, it didn't use one of the tools. We also gave it that it could access a web page, so it can get a URL through Vast and use it. We tried to trigger whether the Gemini API or the Gemini LLM running that you can access, it has no access to the web. So when we tried doing that, it didn't want to. So we gave it access to the web, sometimes to point it to manual pages. In this case, I wanted to point it to the GitHub page of the open source tool, but it never actually took a look at it. And so, okay, I want to actually do this. Can you give me a general overview? So I said, okay, that's nice. Well, we need a diff algorithm. We need to have 2 synchronized Scintilla instances inside of your window. Then you need to visualize the differences, background colors. Scintilla has this concept of indicators, which I don't know anything about. So I actually never tried to work with Scintilla abstraction inside of Vast. So I said, okay, let's see whether the AI can help me figure out what the correct API is, because actually Scintilla and documentation is fairly non-existent. You also need synchronized scrolling, of course, if you have a 2-diff view. If you scroll left, the right window should scroll on the right-hand side, and so on. And the idea is that, okay, let's leverage as much of Scintilla's features as possible. So building the similar tool in Vast, it proposed me a way to move ahead. Takes me a little bit too far to actually read everything. You can, of course, say we need a diff engine, we need the view. And I said, okay, let's first get a window with 2 panes, 2 Scintilla editors, and let's get some text in there. So first, the one of the funny things here, for example, is that it tells me, oh, I can help you explore the STS Scintilla edit pane. And I was like, I don't know that class. Will it exist? There's no such existing class. So that is pretty funny if you work with it. But then he says, okay, you're absolutely right. My apologies. I have hallucinated the class name. So then it started using the function calls to actually find the correct names. So the correct class is the common widget Scintilla editor, which we should actually integrate into our thing. Then another thing, it's a composite part, but that also doesn't exist. I will not walk through all these steps here. These are actually showing things which did not work. So I actually tried those, and it came up with class names which didn't work, and so on and so on. So you can notice me here saying, well, the composite part doesn't exist. You mean ET window. I think in another one I said there is a debugger open. Whatever, I have to ask, okay, provide me the new code, and so on and so on. So I think it's from this place that I can start. So let's interactively start building from this chat as if we are working with the Gemini AI assistant to create this first window with 2 Scintilla editors synchronized. So propose me, okay, let's make a subclass of ET window. Now in this case, you will see we open just the workspace. We don't have a diff for the classes yet, but I define a class, so I can click on this. Next thing we need to do is create the work region, which is the method in Vast to define just how the entire user interface is actually built up. So I'll just merge this in what it proposes without looking right, and then we have an open method. Right? See, so then it gives me an example. So how to use, as before, this is how you can do it. So it gives me that one, and then I can run it. Boom. Doesn't understand create, so that doesn't work, right? So what I did and I will not do it again, but here I said, okay, its code is not correct. See the open debugger, suggest how to fix it. And by the way, look at the Gemini chat window, for example, to open a window. And this is also like a key takeaway we have. If you can point the LLM to another example showing a similar thing that you want to reach, it's going to produce, of course, results much, much faster. I think I tried building a window at several chats, and it always was something wrong, or had many, many different iterations to work through the right callbacks and so on. And I said, well, just take a look at this window for an example. And in that case, it actually provided me blah, blah. Oh, I think I need to start here, actually. Doesn't matter. I'll do it like this, so you have the different ones here. So yeah, the merge view you are seeing, I'm opening all the time. That's the end result, but I will not walk you through the entire creation process. But that's actually the end result, or actually the result, which is our current result, because it's not entirely finished yet. So, but I'm creating another version here, of course. So I will just change this, and then have it open. Right. So now it created me this window with 2 scintilla editors on the left and the right. Nice. I'm already there. So I told it, okay, we have the basic window with 2 scintilla editors. And now we want to open the window on 2 text strings and show these in the 2 editors, produce the code. So again, it goes off and then tells me, okay, just this is the piece of code you need to inject. We need to add the accessors for the strings on these ones, and we have a new open method, right? Boom. So that's the first suggestion it tries to make, and then gives me another code snippet to open the scintilla comparison view on this piece of text and that piece of text. Nice. Boom. Doesn't work. Doesn't understand create. Great. Boom. Okay, we need to do something different. So I told it, well, let's again open the debuggers, find out what's wrong. And then it's like, for example, okay, I keep returning to standard widget patterns instead of the proper ET window lifecycle in vast ET window framework. So at some point, kind of investigate a little bit more how this was actually working. Now, a little bit of annoying, but we don't have a nice diff view on a class definition yet, so I have to manually get these things out. Well, left string, right? Why can't I? Well, we'll see. So it's opening on the, and then I have to. So that's something we are going to fix soonish. But that's right. Okay. So it suggests, yeah, actually, we cannot send these strings to the scintilla editors. We have to first store it in the window, and then actually do it, assign these strings to the editors, to subcomponents in the next step. So that's the correct way to do it. So adding the accessors for the strings, then initialize the text after the realize of the window, and then correct the class side open on method into something else. Right. And next iteration. Boom. I have my window with 2 scintilla editors on either side. So I'm going in the right direction. I think we can create some merge view at some point. So yeah, the next thing I said, okay, this is cool, but let's highlight the differences between left and right. Yeah? And then I said, well, take an example from the existing text comparator browser and apply this to our scintilla comparison view, because I know, of course, we have this existing differences view, and there could be something it can actually use. So the thing that I need to add now is these things. Well, again, have a class change because it wants to inject some instance variables. A bit annoying. Yeah. Right. So that's a diff we will create soon, so that you don't have to do that, of course. We also don't want to do that, so it's coming in. Then some changes here. So it's adding the callbacks. It's actually adding callbacks for the existing buttons which are in there, which I don't want, but at this moment they are there, so it injected it. Callbacks for the buttons to show the equal or to show the differences, which is the modes you can have the current vast differences view opened up on. Then he said, okay, now we need to initialize our comparer. And we add those changes to the initialize after realize method, and I can see what the necessary changes are, and I accept them. And
Johan, could you open a visual editor on the class you're working on? I'm curious to see whether Gemini actually does anything that reflects in the visual editor.
I can, but oh, visual editor. Oh yeah, it's gonna fill my screen a little bit too much. But normally no. You mean no? You don't mean this one, right? You mean the scripts view.
Not a class browser, but the actual visual editor where you define things like fast features and actions and events and.
No. Yeah, indeed. No, actually, I haven't tried, but whether it would be, do you mean the composition editor, right? Okay. No. Well, I'm not going to open it right now because I haven't tried that, but the things we are using there probably will not be the same as you would do using the composition editor.
It wouldn't be the same, but it would just be another point of reference. If you could just open the composition editor on that class, just as it currently is, I'd be very interested.
Yeah. Wait. How do I get there from there? I don't think I would, because I need to change. Maybe if we can come back to that afterwards, I'm glad to do it. But otherwise, it's got to stand in my way. So I will probably get back to that when you finished.
Yeah.
All right.
There wouldn't be any integration, but it would show something. That's what
maybe
I'm
it would. Yeah. I don't use it too much, so that's why I'm not really familiar with doing all that. Okay, let me first continue here, and I'm glad to come back to that afterwards because it's just near the end, so then I can start figuring that out for you. No worries. Then we need to implement the highlighting logic, and this is where actually the LLM provided for me all the things that I didn't know about Scintilla, setting the right indicators and so on. So I'll just add the other things here. Oops. Oh, what did I do? No. Did I not? Wait a moment. I think I didn't put in the right compare, show equal. Yeah. Show equal? No, it's show equal. Why doesn't it tell me? Point frame of the server is not a group number, blah, blah, blah. Oh, why don't. I have to go in. What did I do? Default chain.
Johan, I think that's an NV problem because you're not a group member of the application.
Yeah, which is strange, right?
Yes, it is, but it's not about your code, I think.
No, it's not about the code, but the problem is I'm a little bit, I can't continue adding these things. So maybe I'll just, yeah, it's a bit of a bummer. I was going to run until here and not really much further, but I've shown the differences view quite extensively every time merging this in. The thing was the end product after a couple of iterations, you already have an iteration where you have the two Scintilla editors inside of the merge view, and you have a comparison showing the the things highlighted. So in the same way as I did in here. So if you take a look at these, so for example, and actually this is work we are doing to improve the merge tools in general in VAST. But also, as we noticed, that it will be very important when you are working with an LLM, and that it spews out lots of code that you as a developer, you want to understand and you want to have control. So now you've seen me actually clicking on every piece there. And of course, when it provides an answer, you just want an overview. So an overview of all the merges, and then so that's the next step we will take, and show some improvements in this area, for example. So yeah, unfortunately, I don't know what error here. Indeed, I'm not a member of the supervisor, which is a little bit strange. I tried this in my image. This is my envy. But okay, I'll just stop here and not try to debug this, as I think I mostly show a little bit of the experience. So in our conclusion, or in our feeling, is that the working with this greatly enhances our productivity. You see, you get something really fast. So in our experience, I would say, as my colleague Henry said very well yesterday, this is like a code-first approach, not design or think first. You can really code first and get to a working prototype really fast, and from there iterate. So, and that's also in our experience and the way of working. So yeah. That was actually the last example I was going to show. If there are any other questions, and David, I'll come back to you. I'll try to open that here and get back to you a little later.
Okay, I see a question from Tim. So Tim, wanna go?
Yeah, just while watching you do this, I wonder if it occurs to you, and maybe this is in the future roadmap, some of these things, if the LLM actually tried to execute it, like ran a test or something, it would probably see that it had these errors and potentially could try alternate things before proposing.
Yes.
I guess is that sort of the next generation in your thinking, maybe?
Yeah, absolutely,
Tim.
Yeah, it's part of the next steps that I was going to mention, but there's some. Let me get back to the team at the end, because there are some difficulties on doing that. So let me get back to you later. But it's a great question. A great question. Okay, Johan, do you want me to continue?
Yeah, definitely. And I know what happened. It's changed the default application to the other one when I opened the Visual H Organizer. So anyway.
Okay.
But okay. Yeah. So yeah, you go ahead, Mariano. So I
okay.
Can.
Let me do that then. Okay. So now, 1 second.
Can definitely see the evolution as you guys were going through this and trying it out yourself. It's really cool, actually.
Yes, and so adding the functions is, we started adding functions because we noticed that it was trying to do some things. We are changing those functions, so the things that it can call back to in order to have a better result, because LLMs will often just through regex searches, right? And although it does use find implementers, find references, find senders, and so on, it will also fall back to that. And some of our colleagues have been improving on that as well. And also the validate codes, it gets an error back, or it writes a method that doesn't exist. We give that error back. And one of the things we've been thinking indeed is have the test runs, just having that he has accessibility to run the tests. But we haven't done it yet, just out of time.
Yeah, no, bootstrapping, that's true.
Yeah. Okay, so let me show you now a little bit about what is coming soon, and I will show you a demo about it. So what is coming soon, I would say in the next couple of weeks, it's support for local models, private models, and I will explain the difference in a second from our perspective, and other mainstream cloud models like Opus from Anthropic or ChatGPT or whatever. So what we mean by local model, it's a model that you can download and run it locally, and in the developer's machine. So like you and me, we are developing, so we are running the model locally. So it should be a model that is between smallish and medium size, so that it can fit with the hardware of laptops, of a developer's laptop. So that's what we refer by local models. And that has been our biggest test, and that's what I will demo right now. Then we call private LLMs or models to those that are also local, but instead of running in the developer's machine, they run in your private cloud or in your private server in your data center or whatever, in a EC2 instance, whatever. But it's a local model, but it just happens that you have bigger hardware and you could potentially run much bigger models. So that's something we didn't test that much. We have been testing either local models that fit in our computers and also other mainstream cloud models, as I will show. But we have pending also to try maybe some bigger models on some private hardware. So that's on our to-do. So for that, I would like to show you a demo, which let me start explaining the following. So here you can see Windows, but I am actually running on a Mac, on a MacBook, okay? So in my MacBook, I will be running a few tools natively on my Mac. And then from VAST, I will be, from Windows, from VAST inside Windows, I will be connecting to those tools that are running natively on my Mac. So the first one I will show is what is called a router. The one I will go and show right now is Light LLM, which accidentally, it just happened to have a big security flaw yesterday. So if you want to repeat or follow what I'm doing, pay attention not to use the version that was compromised yesterday. But in any case, there are plenty of routers right there. And the three examples that I will show, either Light LLM, Llama, which is for running local models, and ML Studio, all of these three, the way that we can connect to them, because remember that so far all of the demos that we did was using the Gemini native API, which is what you saw. Like if you open the chat, you see the Gemini models, and this chat was always using the Gemini native API. But OpenAI, the company behind ChatGPT, developed a generic API that is an open API that is called Responses API. It's called Chat Responses API or Responses API. So many different tools already implemented that API. And so the routers, like for example, Light LLM, implement the Responses API, and the same with Llama, and the same with ML Studio, etc. So we implemented a wrapper against this Responses API, and so now not only we can access Gemini, but we can access anybody that implements this Responses API.
Mariano,
so, yeah.
can I ask you a question? I'm having trouble with your accent. What's the word that you're meaning when you say rotors? I'm not hearing it correctly, I think. It's
Rotors?
coming to me as rotors.
Router.
Okay.
Router?
Yeah. Thank you.
Okay.
Thank you.
No worries. I think that's the generic name. Maybe there is a better name, but that's how I know them. And there are other tools, not just Light LLM. There are many. So with that in mind, and again, now I will switch to my Mac, and I will make sure that I have Docker running on my Mac. So if you see, I have a little command to start Light LLM as a Docker container, which you can see here. It's just a simple Docker run. And I specify, you need to specify a YAM file to this Docker container. So I won't show my real file because the real file contains the API keys, but I have this variation that I can show, no keys. So basically, it's a YAM file where you can define the list of models that you want to connect to via Light LLM. And you can say, okay, I want to connect to Gemini 3.1. This is my API key. The reasoning effort wants to be high. There are many different settings or parameters to do different things. So we are not getting into details right now. And then I also have Opus 4.6 that I want to connect with API key. So there are plenty of LLMs available through Light LLM, and each router has their own supported providers. Okay, so I'll make sure I will start this. Right LLM. Okay, so that started the container. And then the other the other tools that I will use from local models, one is Ollama. That's a tool to run local models. So also, if you see, I have a run Ollama server, which runs as a Mac service, but just basically tells Ollama to start its own server. Okay, so I will make sure to start this Ollama server on my Mac. I think I need to, yeah, okay, now I need to, there is a asynchronous step, okay? And finally, the last tool I will gonna show is called LM Studio, which is another tool for running local model, just like Ollama. So if you see here, this is more like UI based. It's a very user-friendly app. And as you can see here at the top left, I have already the server, it's up and running. So it's ready to go, LM Studio. So now that I have the three tools, I will go back to VAST. And as you can see, we're still using Gemini as a prefix. So that's why this code is not yet available in GitHub, because we still need to do some refactors, because we reuse some of the Gemini classes to this new responses API. So we need to rename a few things before making this publicly available. So I will start with this one. So what you see, I need to set a host and a port for where the Light LLM is listening. So if you see, it was listening on this port 11439 on my Mac. So this is the host name of my Mac, and this is the port where Light LLM is listening. So if I execute this, I will go now to models, and you will see that now I have the two that I defined in Light LLM, which is Gemini and Opus 4.6. So I will choose this one that seems like everybody's talking about these days. And I will run not an easy question. It's not that easy. Not all of the others LLMs are able to respond correctly to this one. So what I'm saying is, tell me how to do the equivalent HTTP post from curl, but with the VAST platform. All I know is that I need to use the class SST HTTP client. I want the resulting script to inspect the return HTTP response. And here I paste the cool command. And while Opus 4.6 is running, and now it's starting to, call the different functions to do the different things, and it will get me to good results. At least all of the attempts that I did were pretty good results. But while it works, it will just take a few seconds more. Let me do a parenthesis here and tell us about our experience using local models and these other mainstream cloud providers. And so far, our experience is that all the local models that we try that would fit in a developer's machine, or at least in our computers, they were not good enough, or they were not as good as Gemini or Opus 4.6. They were quite behind. So that's why I did this query to this model, because I know this one can return correctly. Let's see, okay, it went over. You can see all of these thoughts and the different function calls. The guy actually came to this, which, well, in this case, is not exactly accurate. I think it's just missing the transport identifier here. I think this should be HTTPSL. But then the rest, I think it looks good. So basically it gets the HTTP client. Is that the startup? Does the post with the headers that it was in the original cool command, and then does that. So if I run this cool command on my Mac, I get this echo from the HTTP bin. So you can see hello, okay, Smalltalk. So it's kind of an echo of the post. So this is what I should get from VAST. So if I now execute this, I think it looks valid, but let's see. Yeah, that works. So I got the same responses from the HTTP post. So again, I don't want to get into a battle of discussing the different models, but it's just to show you that we have the connectivity to other models. And that's what matters to us. We want to be able to connect to different models, either cloud models or local models. So that was the first question. The second one, now we are going to get into local models. So the first one will be with Ollama. And this will be a basic question, but still, not all of the LLMs can reply correctly. So this is all of the models that I have currently downloaded with Ollama. And in fact, if you go and see Ollama LS, you can see these guys are the same models that you can see in VAST. So I will pick up maybe this one. The query we're going to do now, it's much simpler than the cool command. And it's tell me how to count the amount of current instances of the class color. So we probably all know the answer to how to do this in a Smalltalk. But now it will take a few seconds, because right now, Ollama is loading the model into memory. And this is like a, what was the size? 30 gigabytes of RAM. So it takes a few seconds to load the model. And then the guy will start doing, okay, I will first start by describing the class color. Okay, it looks for the class definition. And then it says that, okay, there's all instances and blah, blah, blah. It looks if there's senders of all instances, and then implementers of all instances. And now it will take just probably a few seconds more. Probably if it's a good model, it should usually validate the code at the end. But as Johan said, they don't do it all the time, even if we explicitly tell the model to do it. So, okay, here's the reply. Color all instances size. So if you click there, you get a workspace. And if I expect that works. So, okay. I mean, we have a local model that was able to reply some basic question. But again, what I want to show is not how good or how bad each model is, but to show that we have connectivity. for the different options. And the last one that I wanted to show is a very tricky one. It doesn't look tricky, but it is. So I will start ML Studio right now. Actually, no, sorry, it's already started, but I will open the chat. And now you will see all of these models that I have available that I downloaded in LM Studio. And I will took Key1 3.5. That's another kind of open source local model. And the question, it's this one, and I will show you in a second why it is tricky. Okay, so the question is, tell me how to change the background color of the main transcript window. Your solution should not include classing or modifying existing classes. So if I open the vast transcript, well, actually now I can show, before doing that, my machine is now, you see, loading. Okay, it's ready. The model was loaded. So now you can see at the bottom left that LM Studio is using 36 gigabytes. And now it's already processing the prompts. So now the model is in memory and the queries are started to being processed. So why this is tricky? And here I wrote some notes of what you would need to do as a human, as a developer, if you would need to answer that. Because first, you need to find out that transcript is a global. It's not a class. There is no class transcript. Then you realize that transcript is an instance of STS transcript class. So then you realize that STS transcript is a huge class that has a big hierarchy of classes. So it has it transcript, it workspace, it window. So you need to realize that there is quite of a hierarchy on this class. And then you will need to start searching for send implementers or methods that could give you the idea that you can change the background color. And at some point, you will realize that there's none in all that transcript hierarchy. There is no way to do that. And actually, you will find out that there's an instance variable 2 levels up in the hierarchy that has an instance variable that's called text widget, which is not clear what is the type of text widget. So now you need to start looking for references to text widgets and try to realize what is the type of that. So that will, I won't go into all details, but it will take you quite some time until you realize that actually text widget, it was set an instance of CW text, our common widget text class. And once you have the CW text, you will look for background methods, but there's none in there. It's only on the superclass or I think it was 2 layers. I think it was in C basic widget or something like that. So again, you need to realize that there's a way to change the background, but it was up in the hierarchy. So that's why I said it was tricky. So if you now go and see this, what the LLM is doing, it's pretty much close to what the developer would do. It would first, okay, I need to change the background. I will describe the class first, then look for methods related to background to change the background color and blah, blah, blah. So the guy will start with describing the transcript. Then it will realize that, okay, it was an instance of STS transcript. And then, okay, describe this entity, this STS transcript. Okay, call it twice, I don't know why. Okay, maybe more than once. And then it gets the class methods of the STS transcript. It's looking for methods to actually change the background until he realized that there's none. And then it will realize about the text widget and blah, blah, blah. So this could take a few minutes because it's running on my machine, but I will open a previously saved chat. And this one, you see the whole list of all of the function calls that he needed to do to eventually come back to the, okay, perfect. Here is how you can change the background color of the transcript text area. And he opens this, and this works. So so you see transcript is now blue. So this local model quite a bit. Of course, Gemini and Opus were quite faster, but it got there. So again, all I wanted to show is that we have this responses API wrapper, and so that opens the box to have other LLMs. And for those customers in the enterprise space that would maybe appreciate some more privacy and they prefer to run local models, they can do it. And I think that was it for my demo. And we are about to finish, so don't worry. I just have 2 more slides to close this, and then from our perspective, we are done. So we already discussed most of this during the presentation, but what is the roadmap on or the next steps or next feature we are planning? One is obviously more IDE integrations. So right now, you can see that the main window is the chat, which can do a lot of things. You can attach files, you can look at the debugger, etc. But we are planning to do more IDE integration. Some examples is like, for example, we want a way to allow the LLM to do code changes reviews. Like you did a bunch of changes, and you ask the LLM, okay, review these changes for me, find potential problems that we didn't realize, propose improvement changes, and so on. Another idea is to not only analyze the methods or classes from the debuggers or the stack trace, as we are doing now, but also get access to the state of the objects. So we want, because we have the live object, so we could potentially not only get access to the methods and the classes, but also to the different objects that are in the stack, for example. Other things are how we can integrate these prompts into the existing browser. So for example, if you're using the application manager or the class browser, where you already have context, like you have a method already selected or you have a class already selected, how can you trigger the different queries or features to the LLM directly from those browsers, so that you don't need to do it from the chat window? So we have many ideas like this that we're exploring or we will be exploring. Another one is code generation. We are interested mostly in generating comments, generating tests. We already did some experiments to generate tests, but it needed us to teach the LLM about the SUnit framework, and so I think it could be done better. So that's something we want to explore: the ability to easily generate comments and tests. Another thing is, as Johan mentioned, we would like to have a way to better apply many AI suggested changes at the same time. If you saw in Johan's presentation, what he showed his diff, hue, and the merge button, that was per change. So we would like to say, okay, the LLM proposed these 10 fixes, show them in a nice UI, so that we can review and merge those changes. And the last one we are thinking is to keep improving the existing tools. If you remember at the beginning of the talk, where we list the amount of existing tools and the list of existing functions. So we have a lot more ideas. One that I think was discussed earlier today, we have a function that validates the Smalltalk code, and I think that one can be improved a lot. Right now we are doing some basic validation, but we are already working in a more sophisticated validation so that we can detect more cases, like classes that doesn't exist. For example, if you send class type messages to a class, that should be easily validated. If you have literals like strings or numbers or whatever, it could also be validated what message you send to those objects. So a lot of code validation improvements. Another one, it's code execution. Someone asked, I think it was you, Tim, what about letting the LLM execute that and realize by its own? We thought about this, and it's extremely easy to just add a function to specify code and be able to execute it. The problem is the security aspect of that, because I mean, you don't know what could be the proposed code of the LLM to be executed. So I know, I think in the Faro chat application, they have some sandboxing, which is great. And that's something that we are going to investigate, try to do some sandboxing or some kind of security. I don't know, it's still not clear. That's why we didn't add it right now. I think it needs to be carefully analyzed. And another tool that we also thought about improving is the type inference. We are planning to add one or the necessary functions to try to tell the LLM what could be the possible types of a given variable. That should probably improve the response a bit further. And I think that's our most clear, at least, functions or tools that we want to improve next. Something we improve a lot these last 2 weeks is the scoping. And how to, I think, Tim, you also asked this on the chat. It's, you have the context length limit. So when we start playing with smaller models, we realize that sometimes we will reach that limit because the LLM was calling find senders of print on. Boom. We were 10,000 results. So what seems easy on an ITE might not be possible or might not be the best in the context of the LLM or our tool. So what we have been doing is we improve all of the tools a lot, like find implementer, find senders, find referencing, etc., to add additional optional parameters to define scope. So the LLM could say, find senders, but only in this class, or in this app, or a maximum of 10 results. So then, if any of those conditions are met, we throw back a warning to the LLM and say, okay, we only give you back 10 because the actual result was 10,000. Take another approach or scope it, or things like that. So a lot of this, we have improved this over the last 2 weeks or 3 weeks, where we actually start testing maybe more limited models, mostly the local models. So finally, as I said, we did this open source so that we can get feedback from you guys, ideas. We want to know if you have thoughts. We will be very happy to listen to them. And I put there some links at the bottom. One is the GitHub repository for this project. And it's very cool that we already have folks in the enterprise space already using this tool. And actually, we started receiving the first contributions. So that's awesome. We hope to get more, and that's why we decided to do it open source, among other reasons. And finally, there is the responsible evolution link that I said that I was going to share. So if you want to read more, I'm welcome to do so. So I think that's it. I don't know how we are in time, but if someone has questions, we will be happy to take them.
I have
Mariano. Oh, go ahead.
Have you used the assistant to build user interfaces?
Not me, not personally myself. I think Johan use it a bit for this. I think we use it most. I mean, what I have seen used for UI is while building the Gemini chat window itself. Like none of us, like Johan, Kris, and the rest of the vast team members, we were not really experts in UIs. So we have been using this tool to develop the tool itself. And many of those changes or those uses was in the UI. Like, for example, the other day, what was what I did? Well, I don't remember, but I did something. Yes.
Yeah, the things I showed, Koen, is actually the window. It's completely produced by Gemini. And one of the things I didn't show, but at some point, for example, I told it to remove the buttons that it could do. At some other point, I said, look, I want a merge button at the bottom and a cancel button. And I said at the bottom, and my thought was it's not going to be able to understand what I mean because it doesn't have a visual feedback of what the user interface looks like. Funnily enough, maybe by coincidence, it made it like that, and it put two big buttons at the bottom of the screen, so of the entire width. And I said, no, I want them to be on the right-hand side. And it came, maybe I should look it up somewhere in one of the safe chats. And he said, oh yeah, better suggestion. Let's move. I moved them to the right. And they will also now take the natural width of the text inside of the button. And I just applied the code and it worked. So yes, but these are mixed results, right? I'm telling you about the cases where it did work and other cases like it didn't work, right? But yeah, I've been using it to build this user interface for the merge window, for example. And sometimes we also ask it stuff about the Gemini chat window itself to do it. But nothing else yet.
Okay, I have another question. Have you done refactoring of existing code? Big refactorings, I mean, with the assistant?
Not much yet. I did. So actually, one of the examples I showed, well, I went too quickly for you to realize, but of course there was quite some code duplication in there. At some point, I told the assistant to say, "Hey, let's clean up the code a little bit here because we have lots of duplication." And of course, it always comes back to, "Oh, excellent idea," but it does propose some things there. But no, we haven't applied it yet to say, well, refactor me this code base. That's not something, that's not an, well, I didn't do, maybe one of my colleagues did. Sometimes, I don't know.
I think for that, it might be useful to have these better ways to apply AI suggested changes before we start to do big refactor, because right now, if you get like each suggested change as a different window, it would be a quite messy to be able to easily do all of the changes and merge them. So I think we need to do that first, and then I think we will be better prepared for doing like big refactors. That's in my opinion.
Okay, and then I have a final question. I saw on the chat, and it was also mentioned that some people think about test case generation. And I wonder what that means. Does that mean generating tests for existing code, or is it generating tests together with generating new code? And I was thinking, how would the assistant help in a TDD situation where we write the test first and then it writes the code to satisfy the test?
Yeah, I think it's a good question. Maybe
it's especially. I don't want to interrupt, Mariano. No, it's especially the last thing I'm thinking about. That's why we will be adding the run the tests function, because this is something you can read that other people are doing. You define some tests and then you let the AI generate code until it satisfies the test. And also when it adds code to it, and that's mostly the places where they add it automatically, that they have to run the tests before actually providing you with the final answer. Haven't done anything like that, but it's definitely on our minds. The presentation here comes 2 months early.
So, okay. Sorry, but I have a really last question. Will you present this or the evolution of this when you are at ESEG this year, or are you going to ESEG?
We are still
we are discussing.
Evaluating that. But if we are not to ESAG for whatever reason, we will be happy to give another presentation in a couple of months to see where we are. That's not a problem. We're always happy to show what we're doing. Mostly, if people find this interesting, we will be happy to present in a few months where we are. And it's evolving pretty fast. Like if we compare to what it was 2 or 3 months before, it's evolving quite fast, and we have many team members working on this. So I'm pretty sure that in a couple of months it will be quite of a difference. So yeah.
Okay, thank you. It was a nice presentation.
You're welcome.
Thank you.
Okay, I see someone else. Bino, want to go next?
Yes, love what I see here. Nice experiments. I've been doing similar experiments, but I've been working from the outside with a coding agent. I've been using Claude Code to drive Smalltalk. And I want to point out that that gives you some extra things that you might be missing if you're going to work only in the image and only with one LLM. What the coding agents have built is a lot of infrastructure for context management. You mentioned, for instance, that if you want to do a S-unit test, you have to tell it how to do that. And a coding agent already has skills as a infrastructure for handling that, so it's not always in the context. Coding agents will also spin up multiple LLMs in parallel, and it has sub-agents and stuff like that. So it's a suggestion for you to wrap up all your functions into an MCP server, and then readily people can work with their coding agents with what you're building. And I guess that will work nicely in parallel with what you're already developing for doing the in-image human-in-the-loop stuff.
Yes, absolutely. And in fact, I totally agree. Having an MCP server, it's in our to-do list. Maybe I didn't mention that because to me it's not clear yet if it will be under the same project or it will be another of the different AI initiatives that we are doing with VAST. So that's why when I talk about maybe the roadmap, I was focusing on this particular project, but the MCP server is clear. It's clearly in our minds, and I think your suggestion makes a lot of sense. And it was also mentioned to us by a few customers already. So I totally agree. I think it's something that we will be doing sooner or later. So thank you for the suggestion. I see Santiago. I see your hand raised.
Yes. Hello, Mariano.
Hello.
I wonder if it is possible to add something like a skill, for example, to have maybe once you analyze a model, you learn something and prepare a skill, and in the other way, in the other instance, you look for the same things. It is not needed to analyze all the code again, or is it possible to feed the assistant with markdowns, with instructions or rules?
No, at the moment we don't have like a concept of stored memory or these stored skills. So that's something that we would still need to explore if we can add that as well. So right now, if you would want to do something like that, you need more extend the system instruction. So that there's no function for like the model to like add to a memory that it can retrieve later, as some other chat applications do have. It's something we haven't explored yet.
Okay.
Okay. I see Sean McIntosh. Okay, go Sean.
Well, I was just going to point out, using the MCP model, I was able to chase a performance issue in the Smalltalk VM by basically just saying, here's the GitHub source, and it constructed a, an Xcode build environment on my Ubuntu machine, headless, and built VMs, and then changed C code, and then launched images, and then looked at what was going on in the image and iterated through to figure out where the problem was in the C code. And it was actually an issue that's been there for decades, and no one could really figure it out because of the interactions between what the Smalltalk image is doing and the actual virtual machine. And that really just showed the power of having this type of environment to do development in now. And I think if one was to take, the code base that you have, and you could just ask an LLM to port it to Squeak, and it would do it. And I don't think people really understand how profound things that are going on in our industry. So anyways, there's a lot to be learned, and great presentation.
Yeah, and thank you, John. And it's always a challenge to stay up to date, because it's evolving so fast. There are like new concepts all the time. So I think that for our perspective and based on our customers, as I think I pointed this earlier about the responsible evolution and the fact that the innovation only brings value when things can stay stable. And so I think that we need to be, from my perspective, we need to go a little bit careful and not to follow every bleeding edge idea of technology. So we like to maybe, if necessary, go slightly slower, but more confident of what we're doing. Because as you said, these things evolve all the time. All the time there's a new concept, a new framework, a new idea, but we need to be careful of the results. Okay, I see David Mason. You want to see your hands raised?
Yeah, I just wondered if Johan had the visual editor available for that.
No, actually not. I'm not entirely familiar with what's needed to, because I kind of now found again that I have to open it on all classes, but if you take a look at that class, it's not showing the visual editor there. So I only have a familiarity with creating from the composition editor, creating the user interface. But
even if you open it from the Visual Age Organizer, like all you should have to do is add the application to the viewed list of applications in the Visual Age Organizer. Click on the application, and then you should see the classes in it, and then you should be able to just double click on the class, and it should open the visual editor for you.
Yeah, but it's opening the editor, but the visual part is actually grayed out, because I guess I'm not too familiar with what is needed for it to reinterpret it. If you build it from the composition editor, it's going to show you the visual editor, but this one was generated directly in code, right? And well, I can do it. I can click on this one, but it's actually graying it out, and I can, well, let me quickly show it to you.
That tells me something too. This is what I was trying to get, is what do you see from the visual editor, and you can't see the visual editor. So
yeah,
that's
so this
the answer. All right.
Yeah.
Thank you.
So this is the thing. Yeah. So, but this also is the case with if I literally manually implement it, right? Then I can't open the visual editor. I can just get the code editor here. I can get some of these things open here, but not the visual editor of the composition editor. I'm not immediately familiar with what's needed to make it interpret and show it there, or whether it would only be happening if you create it from the composition editor. So that's why I have that thing.
But it was helpful to see there too that you could see the vast features, the actions, the events, and the attributes in the class browser, even if it can't see the visual composition editor. Yeah. Thank you.
Okay, great.
Okay, I see Casper.
Yeah, I don't know if you can hear me.
Yes.
Cool. I just wanted to say thank you. It's wonderful to see what you have done. It's very inspiring. It's different from what I have been doing, but it's still in the same family. There are two things I wanted to tell you, and one is that in my experience between Gemini, Claude, and Grok, Gemini is clearly the worst thing to work with regarding Smalltalk. And my belief is that it is an extremely clever machine for programming in anything but Smalltalk. Whereas the other two I mentioned, Claude and Grok, has two advantages that are interesting for you to take a look at. And one of them is, in particular, Grok is a maiming stupidity in the sense that it loves tools. I have had it break my limit of more than 130 tool tests while I asked it a single question. Okay, so boom, 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 boom. So it's really interesting. Claude is not that bad, but it has broken the 50 limits tool calls as well. So they're different. And in my experience in particular, Claude has better understanding of Smalltalk and Pharo than Gemini. But that is my experience. And that was why it was so interesting to see that you were working on the other one. That was all I wanted to say.
Okay, thank you, Casper. Yes, we have been using Gemini mostly because, we at Instantiations, we have a acceptable use policy that governs the AI and machine learning tools that are available to Instantiations employees, and combined with our privacy policy, it's what tools we can use. So we have been using Gemini from that reason mostly. We did a few maybe experiments with Opus, as I show you, but we didn't test both enough to be able to compare or to have a meaningful comparison. All I can say is that Gemini, for us, it proved to be quite good and help us for the things we needed to do. But maybe
Wonderful.
Opus, it's even better. But that's something that we don't know. But so thank you for your feedback. I take it, and we might be able to do some more experiments with Claude or others. Okay? Thank you, Casper, and thank you for your previous talk. We watched them, so thank you for your previous case. Yes, Francisco.
Yes. So yeah, first I think I'm going to stop the recording so we can keep chatting, but and I also need to be leaving soon. But before that, I have a question, which is precisely around how. So do we know how the models are trained or Smalltalk, if they are trained, or are they, or can we? Let me rephrase. So of all the Smalltalk dialects, they are different, so they have different ways of producing UIs. And in your experience, you got a fresh model without giving too much context, and is able to produce just from the very start window, or you have to be giving all that information in a lot of in markdown files. Now incrementally you will teach them how the system is structured. That's where I'm heading. So because if it knows already, then it means that during the training somehow it was able to go through some open source repositories or mailing list, and where it could learn something about visualization. And how about the other Smalltalks? And my question is, do we need to get together as different Smalltalk communities and try to, okay, let's try to have more presence in the web, or even talk to the to the model providers. Because if Anthropic or any of them, they say, well, we want our models to produce better Smalltalk code, they don't have anyone in particular to talk, because there is no association for all the Smalltalk. So each one is looking after themselves in a way, no?
Henry?
Yeah, just to answer that, I mean, one of the big problems and one of the reasons we have to use tools in order to do this development for Vast is because there are so much Smalltalk code available online, and it's in all the other dialects. So from that point of view, just providing better training data to the models by clearly labeling what dialect of Smalltalk. If you're putting code on GitHub or you're using Tonel to file it out or something like that, I assume would help train the models to be able to differentiate different dialects of Smalltalk and generate better code for whatever dialect you're currently using, as long as you tell it what it is. But that's sort of one of the reasons why, without tools, even if you describe your system, it will still or an MCP, it will still hallucinate code on a regular basis, right? So.
Okay. Yeah. So my question was on the back of Mariano. I don't know if you know Hernan. Yeah, you know Hernan. So he's been doing some project where he has to train data for images. So he knows a lot about how models are trained. And yeah, we were discussing, okay, maybe or he was coming up with the idea, it would be better if we get together as a Smalltalk community, the different, and be able to present a common source where the different model providers can train on Smalltalk or can get Smalltalk code. So
yeah, one thought I have, Francisco, there is that one thing that should be considered on the case of Vast is that it's a commercial Smalltalk. So we cannot basically train and make it available, because then it's against the copyright of the.
Yeah.
So, and the same will come, like if you go to talk to Chemtalks and you want to make the Chemtalk code.
Yeah, and that's basically, I was thinking also the same. I mean, I previously worked in JP Morgan, a massive amount of code, and all the companies will have the same problem. So I don't know how that problem is solved if you have to get the model and then do some extra training or the fine tuning, but nobody seems to be doing that nowadays. So that's for me, I don't understand, but that's my question. Yeah, thank you.
Okay, no worries. I think John, maybe you have something to add.
Well, I guess I try to comment about training nano LLM. So, you know, I actually pulled all the source code from Squeak source and packages their quiz, and about just under 300,000 source files from GitHub. And so, you know, I ended up with like 12 to 14 gigabytes of Smalltalk code. And that then generated, and the problem is that it generated about 48,000, you know, question answer pairs that you feed to an LLM. But then who is going to look at that and decide if the questions and the answers are valid? You know, and that, well, maybe it could be a community project, maybe that, so that you're ending up with information that is being fed to build an LLM that, you know, has quality information. and that's the challenge, I think.
So sorry, I'm not sure if I understood you correctly. So you're saying that you train your own model with a lot of Smalltalk code that you gather from different places.
Well, but also from the various Smalltalk books.
Okay.
Books on programming. There's also the concept that you actually pre-train SIPs, that you train the system to understand English, the English language, so that it can answer in questions in English, or whatever language that you pick for the face training. But you're basically layering on top of that domain knowledge.
Yeah, but the
issue
it's important.
The accuracy of that.
Yeah, I was thinking that it's important to select what code you train. Now, as you said, you said from books because it's good code. You don't want to be training on code that is not very.
Yes, and unfortunately, ESUG, made available a huge library of Smalltalk literature that I, used to feed into the system.
Okay.
Esteban, I see you're speaking, but you're muted.
Okay, yeah, that's why I was moving my mouth. The thing is that with the corpus of code we have in the Smalltalk, even if we put everything together, I don't know if it's large enough as to be the large language part of anything, because it's like in comparison, it's not large enough. Even if we put like all the source code of Fast and Faro and all the commercial. Well, if we put like the customer's code, of course, that would be maybe more important because we have huge systems there. But it's like, I think that the good code is just basically part of having large corpus of code out there. It's not that you can just curate what's fed into the model, because otherwise you will end up with even less corpus to train your model. One thing is that what John mentioned, that you can retrain a model. That's something that I've read that some some labs do to make a small corpus more significative, but I don't know how that actually works on a low level, but that's an approach I've read about. Johan?
Yeah. Well, I don't know how it does it, but for example, in many of the chats I've been running through is, for example, I told it, well, I want something like the diff match patch algorithm, and it finds it knows it points to the Google implementation. It has it in many different programming languages. Doesn't have any knowledgeable thing about Smalltalk, but it just produces the one in Smalltalk. So it's actually translating towards the stuff you have to do in Smalltalk. So it's not that because it doesn't know any Smalltalk that doesn't help creating the Smalltalk code. So it seems. Right, and the same thing happens with the Scintilla editor. The Scintilla editor, it knows this as the C library, and it just translated the stuff, and it tried to find the things. But sometimes it was proposing me pieces of code which obviously would be working if you were taking a look at the C source code. But then it was trying to validate it, and it was like, oh, this identifier doesn't exist in Smalltalk. Where is it implemented? So it was invoking the functions to try to take a look. Where can I find this this representation? So it finds something, and it kind of throws whatever it finds at it, and maybe it works. So this also helps, right? So it's not, and that's what we've noticed, and maybe in response to Casper also still, the fact that we have been using Gemini is, of course, yep, that's what we've been doing, but the tool itself, as Mariano demoed it, but like with a focus on local or private models, for example, but in general, we will be able to use, you would be able to use any other LLM, so not Gemini, inside of the tool. So that's the idea. You can experiment yourself what will work best, and we'll probably be doing that in the future as well. Yeah. That's
okay.
it.
No. Have a question?
Good morning. Yeah, actually, contractor for Syncom, so I can't talk about that stuff under NDA, but I can talk about my own projects and things. What I found is that giving the API, the LLM tools to do bulk queries, it can get much more specific about what it wants and get back the results it wants. When you give it too much information about things it doesn't care about, it gets very lost very quickly. But the other technique that I've seen other environments use and I've used is to, after a while, when the context window has grown, ask it to summarize its own context window. And then you can throw away the old chat and keep the new stuff, and it will, in a rolling fashion, stay much more on focus about what it's trying to achieve. You know, you keep the system prompt, you keep the original developer's goal, and then everything in between. It's done 50-odd API calls at that point, and it just doesn't need that information anymore. It's found the class it wants. It's found the selectors to use. So there's a project that recently got published about adding engrams to large language models. So this is like MOEs on crack. This is not supported by LM Studio or Olama yet, or anyone really. I think it's not going to be very long. Every part of the LLM's performance increased. And it works effectively the same way, which is it caches particular results that are useful. So this is just you know, a small little nugget of experience that I've gotten from my experiments. Yeah, it was very interesting seeing where you guys are at and where you hope to go. I wish I could talk more about it, but you know, NDAs. Can't hear Mariano.
Yeah, sorry, but no, yeah, thank you for that thought. Yeah, I think it goes in line maybe what I see Greg Lata was saying in the chat. I think it's like we have the two I see like two paths. Like some people want to have the information pre-trained or either by fine-tuning, and some people say, okay, no, let's go with the tools path where the LLM just grabs what it needs to. So I don't know. I think those are valid approach. Our experience so far has been with these tools or function calling or tools calling. That doesn't mean that we would not try in the future maybe having a fast own fine-tuned model. That might be something we would explore in the future, but so far we are taking this route of the like what Greg was saying in the chat.
Yeah, so there's LM Studio has this draft model thing where you run a quick LLM and then the bigger LLM, and it speeds everything up by 2 to 3 times faster usually. One technique that I haven't seen anybody do yet is, as the LLM is generating tokens, having a smaller LLM rewrite it. So you know, when I use this for Smalltalk, it more often than not suggests squeak classes and selectors that I don't have, and then it will bounce back and say, oh, okay, I can't do that, I need to go and find how to do that, and it will just do this over and over again, which is where in a LoRa model that's trained on your specific dialect is useful. But then suddenly you can't use Claude's cloud services, you can't use Gemini, you can't use don't use Grok. It will steal everything you've ever done. Just gonna put that out there. There is no guarantees about any kind of privacy whatsoever with Grok. Anyway, I'll get off that high horse. I think that when doing local model stuff, having a fast, small model that knows your specific dialect as a rewrite over the response from a larger model could save a lot of time. It could. I don't know. That's a definitely an out there project, not something that I have the money or tokens to burn on.
Really interesting. I was not aware of that, so thank you for the ideas. That's something new to me. Henry, I see that you have your hands raised.
Yeah, so last ESAG, sadly I don't remember his name, but there was someone presenting on the experiment doing a train model versus sort of RAG, which is, I mean, basically what you can do with tools, and getting better results out of the just having a standard model augmented by RAG than actually pre-training. So that's also one reason why we sort of went into this direction rather than trying to train our own models. But the sort of hybrid approach that Willow is sort of mentioning, where you have a small model that can give good suggestions and then have it followed up by the actual large model with access to tools, that's a very interesting approach. So yeah.
Okay. Thank you, Henry. Sean, I see a question.
There was a comment about memory, so I'll just share that I use my Jira stack, Atlassian stack to remember things. I just say, make Jira, read this Jira, update the Jira, and Claude or XI, they know all about Jira, and they make wonderful Jira entries, and then I can say, take the file out and attach it to the Jira, all of that stuff, so it's exploiting, technology that it used for the last, 50 years, which is taking advantage of.
Okay. Yeah, I have used not the Jira integration, but just I think it was 2 days ago, I asked Gemini to analyze a wallback, and the guy immediately came to propose fix, and we met with Esteban, I think it was last Friday. We evaluated the change, the suggested change, and we looked, it was great. And then I asked him, write for me a title of the ticket and a case description that I can then submit into my own backtracker system. And it was really, really nice. He wrote a nice title and a nice markdown-based description that I could just put in our internal system. So yeah, those kind of things are nice. I agree. Yes, Casper?
I just wanted to mention a small thing, and that was there on at least in Faro there is a teapot, which is a server. Okay, I opened my computer to the outer world. Then I was able to from something like Gemini or whatever you are. I tried them all. So ask it to go to that website and call for this site, and then would actually activate code in my Faro, so that what happened was that from the hand-on web-based Gemini, it would actually end up manipulating the code that was actually in my active Faro on my computer through this website shifting. So, and that actually showed something that was brought up before about caching, because if you change, ask it to do something different, the cache of Gemini and Claude and Grok and the others freezes, so that if you change the code and you ask for it again, it will look in its cache. So there is an issue there that actually means that you have to, it is not in the LLM that the cache is, it is in the code that is accessing that. So I have tested it from 2 directions, and if you do it through the web, there is no problem. There is problems. If you do it directly as you do, it should probably not be an issue. So that was cool.
Okay, thank you for sharing. Thank you, Casper. Francisco?
Yeah, so I mean, it's just a bit of reflection of, I think that when integrating, I think that must have some decision you took before, no? So when integrating an LLM with a Smalltalk, you had two paths, either go to make Smalltalk behave like the other languages and try to use the power of Claude and all the rest of the agentic tools, or make that power available inside the Smalltalk, which is what we are more use and prefer in general. So the more Smalltalker way. So the problem with that is that there's a lot of things that are happening in the agentic area now. So and I'm not sure how. So for example, one of the nice things from Claude is that you have the commands like /init. So you give some context, you say a repository, and in a Smalltalk, what are we going to give? I mean, an application in case of Bast, or I mean, have you thought about that? And that also changes because you're new to a project, you go with this /init and say, okay, look, have a look at this piece of code and tell me something, because I knew I don't know anything. So have you thought about putting that sort of commands inside your tool?
Not I mean, myself, I didn't think about that yet, or maybe I did, but I always come back with the security aspect or privacy, or so we need. I'm not against that. I just would, if we do it, we will need to be extra careful with what it means. From, like, for example, it's like evaluate code. It's a similar aspect. It's like I don't know how, like, I don't know. I haven't used those commands that much, so maybe I'm not the one to give you an answer. Maybe Johan, knows, but the only thing that rings my bell is just the security aspect. But I don't know, Johan, maybe you have another thought.
Yeah, the security, but the control aspect as well. But yeah, what you're mentioning is that, and this is one of the thoughts we have, is also from the outside to introduce your Smalltalk inside of another agentic system, that we would implement an MCP server, which basically would be offering the functions we are offering to Gemini to call back into, or we are offering the functions to the LLM to call back into the image. Yeah, you would expose it to the LLM as an MCP server. They're actually basically the same thing, so you can call into, and some people have mentioned, like John, they have implemented, and some other implementations exist. But yeah, if you ask an LLM, that's what sometimes we did, you ask it, give me suggestions for tools you would like to have a better understanding of the Smalltalk image. One of the things it suggests is, just give me the evaluate tool, right? which of course it allows you to do anything, and that's what Mariano more or less says with security. So the approach, we're definitely not excluding those things. I mean, if you would take it, you could offer it the function, evaluate this code and do anything with it, because some of the things that when I started out the chat, it offered me, said, well, we first need to create an application here in Smalltalk, and then it gave me the code to execute, so I could create the application programmatically, for example, that it would be able to do itself, right? So it could be able to just launch it, and all the merge windows I was opening, or the things we're merging in, you could just say, well, let the LLM do it directly into the image. Maybe that should be a possibility, but I think in most of the cases, I would like to have some control, because I've seen what it tries to inject in. At least you want an understanding of what you're going to get. Of course, sometimes you can go a lot faster and just let it generate stuff, run the test, for example, and you set up some tests, just let it generate stuff until it works. And that would be a really nice experiment as well. But at least our ideas are that we want to also have the human in the loop as part of that, as part of the AI based development, let's say. But yeah, I mean, all these things are possible. Just the time to experiment on them, I think. I hope that's an answer to your question. If not.
Yeah, thank you.
There's
only one thing, which is the MCP server, because so my experience is limited, but I remember I put like an MCP server to look at the Gmail, so it would open a browser and start looking, so like crazy, man, clicking everywhere. So, and obviously it burned a lot of tokens. So if to look into my mails, I tell Claude, well, you have some commands like search all the list of the emails. So a CLI for looking at the mails. Can we have a CLI for a Smalltalk to start doing? Okay, open the class, see the method, blah, blah, blah. So you wrap everything into CLIs, and then you can the server do the. Yeah, you don't have all the experience of being immersed in the Smalltalk, but I think that the trend now is more and more towards let everything happen automatically, even without human reviews. So we can stay on the more conservative path, but I don't know. That's my point of view.
All right.
Henry, something you want to add?
Yeah, I just want to sort of let the LLM do what it wants. Maybe that's a good experience for a new application or anything that you sort of develop from scratch with the LLM, because then you know what to expect. But when you're working with a legacy system like the one we have here, I could ask it a question about the small UI annoyance that I had with one of our widgets, and it would sort of point me to the right place to change in order to fix that thing, and it would even give me code that was working. But in the process, it broke the architectural layering of how our frameworks is structured. So it still took developer intervention to sort of rewrite the code that it suggested into a way that fit into the way our frameworks work. So that's another reason why you want a human in the loop when you're working with legacy systems, because the AIs are smart enough to figure out Smalltalk. They're smart enough to write working code, but they are not smart enough to sort of get intuitive understanding of the architecture of your whole system. So for that, you still need humans, I think, at least. So.
Yeah, that's a good point.
Yeah.
If I may add to that, a little bit, is when working in other languages, cloud code, we work with a much larger granularity. You know, you have a pull request, or maybe several variants of pull requests that are created while you walk away from the machine, and that's something that the human in the loop is still there, but at a much larger granularity. So much so that you can go to sleep and look the next day at various options that have been generated, and you can choose one and try to test that one out, which is rather different than this UI you've shown now, which is very fine grain human in the loop, which eats a lot of attention, which may not be necessary because there's a lot going on in the agentic arena of having the agents test the code and judge the code and suggest which of the variants is the best one and stuff like that. So
that's
I
true.
guess I agree with Francesco that we have to look at what the agents are doing now and what's happening there and how they are used in other languages.
Yeah, that's true. So right now it's really fine-grained, but we think we need to build the basic building blocks, and then you want to see it at a more complete answer level, and you want to maybe even go further, have it completely rewrite your entire system and present you a pull request, for example. But that's something we are indeed looking at and trying to evolve towards, so that the human in the loop doesn't have to be on every little step, but maybe looking at the larger pieces. So, and all depends, of course, of what you find most interesting, whether your tests are green or your architecture is nice or the code is nice and all that kind of stuff. But yeah, absolutely. We're not like excluding the fact to reach there, more larger suggestions coming in, but still find it important that there's like a developer augmented tool, let's say.
Okay, thank you, Johan. Yes, I think a hands raised. Yeah, Willow.
Oh yeah, I just want to talk a bit about the autonomous agent stuff. So one of the reasons why Kubernetes is KubeCon just recently happened or is still happening, and almost every presentation was just, you know, another AI presentation. And that's because firing up a workload, having it run and then get a result back and then throwing it away over and over again inside a cluster is something that you can get an LLM to do to test out options and then collate that whole thing back in, you know, when it's done. So we're talking about, you know, clusters with hundreds of machines with massive GPUs in them, burning through tokens like they mean nothing. Just turn on the money pump and see what you get out the other end. This is massively inefficient. As a single well-trained human paired with, you know, an LLM, where the augmentations, right, from the human brain are just better, right? Maybe one day we're going to be looking at this and go, oh yeah, well, in the 70s, we had gigantic computers that took up an entire room, and now they're on our phone, and our phone is 1,000,000 times faster than those machines ever were. Maybe one day we'll have that equivalent of the giant cluster of GPUs presenting every kind of potential option and delivering it back to us in a couple of seconds in our pocket. It doesn't exist yet. It doesn't mean that the approach is wrong. It just means that it's premature. I think is my take on it. It's premature when we have well-trained human brains that can orchestrate this stuff better. Well, you know, areas where this stuff really excels is protein folding. We have umpteenth options. Let's just throw it at a giant cluster and see which ones come back with positive results. Do we need that for coding? No, actually. A lot of the simple things that you can say to an LLM, like, hey, rename this class for me. I can do that faster with a mouse. I can. The Smalltalk code to do it is almost exactly the same sentence. You know, things get interesting when you don't know the code base, when you don't know the architecture, and you can ask it questions about that stuff and get answers back. But certainly, if you want to modify legacy systems, you need a massive amount of testing to be sure that what you've changed actually makes sense. And don't let the LLM change the expectations based on its own intentions, which it will do. You know, it will happily modify the code and go, oh, the tests are wrong now, I'll change the tests. I think there's a lot of interesting stuff going on, but also a lot of it is just utter nonsense. I remain firmly in the skeptic camp, though I do use LLMs to do transformations. I have a pet language that I have a YAML grammar for. I decided I just didn't want to use BNF. And I get it to transform that into tree-seated grammar. So now I have syntax highlighting for my experimental language. As a transformation, right? The inputs and outputs are understood, and what's in the middle doesn't matter as much. But when what's in the middle matters, which is the truth with an actual program, you just can't do that. I'm part of various open source communities to do with self-hosting, and unequivocally, any project that has been AI built, if it's got like a Claude.md sitting in there, the community will instantly distrust it. We've had numerous projects fail, go out of scope, have massive security holes, all because they've got the start spec and then the end program, and they don't care what's in the middle. As programmers, we really have to care what's in the middle.
Okay. Yeah, I think we agree that the human factor. I mean, from your perspective, Willow, I think we agree with you, and that's somehow related to our responsible evolution message that I wanted to try to cover earlier. There are a lot of touching points in what you said. So yeah.